And I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. And thanks again for joining us for today's MSDN webcast, Visual C# 2010 Soup to Nuts. Today is Part 6, Branching and Looping. And now, without any further delay, I'm going to turn the floor over to today's presenter, William Steele.
Thank you, Tracy. I see I have an error on my slide deck. This is Part 6, not Part 5. Anyway, so today is Branching and Looping. We're going to be talking about the various ways C# can actually alter its course, if you will, when it's actually executing your code. And the two main mechanisms, one is actually a derivative of that. Branching is basically a very simple decision, left or right, forward or stop, simple if kind of statements. And a derivative of that is a whole bunch of if statements kind of together, which we in C# talk as, call a switch statement. So you can have multiple paths, if you will. And then the derivative of the branching is something that we call looping, where we can actually re-execute the same code over and over and over based on some conditions that we set similar to the if statement. So we're going to take a look at all of these types of branching with the if and the switch, and looping with the do while, the for, and the for each statements in today's webcast. So let's start right away into branching. Branching is basically a very simple mechanism in coding where your execution makes a decision. Based on the results of that decision, it'll either go left or right. It'll do one thing or the other, basically giving you the ability to conditionally execute code or not. And what we mean by that is it's making the decision based on parameters that it's received, comparing one value to another. And if you remember last week when we talked about our expressions, an expression is the resulting of a mathematical formula or an evaluation of some form that returns a true or a false. So you can see that the if statement, being a very simple statement, simply is looking for a value whether an expression is true or false. When it is true, it will do one action. If it's false, it might take another action. Interestingly enough, we can actually have code that decides which action to take and utilizes either one. So, for example, I can say if condition A is true, then do one bit of code, else do condition, do a second bit of code. So if a condition is true, process it one way. If it's not true, process it another way. And we use the else statement in conjunction with if to accomplish that. So a lot of times you'll hear people talk about either an if statement or an if-else statement. And they both refer to the same thing. It's just that the if statement is just checking on one condition and executing it regardless of what the other condition is, or the negative of the condition is. Now, a combination, a more advanced version of the if statement for branching is one called a switch statement, where we use the exact same expression syntax that we do in an if statement. However, we can have multiple results. And the way this actually works is instead of the expression returning a true or false value, it's actually going to return some kind of more complex value. And then what we can do is check that complex value and compare it against a list of known results that we expect. And if it matches any of those results, we can execute the bit of code that's associated with that result. Now, there's some modifiers that are available in the switch statement that allow us to make the switch statement more advanced. So, for example, we can build a switch statement that has a simple bit of functionality, but maybe we have another condition where more complex interactions would occur in addition to one of the previous conditions. In that case, we can actually use what's called the go-to statement, and the go-to statement allows us to execute an additional bit of logic, whereas the normal switch statement would only allow you to execute the one condition. The go-to statement allows you to add additional functionality to that. Now, interestingly enough, sometimes in a switch statement, none of the answers is available to us ahead of time. And if that's the case, we can actually use another statement that's called default that will always get executed if it can't find a matching value from its expression from the case statements. So the default will trigger when everything else basically doesn't trigger it. Then lastly, the one statement that's going to help us a lot is a statement called the break statement. And the break statement basically says, okay, I have found my matching case. Do not continue processing this any further. Exit the switch block of code. And that allows us to execute just that one piece of code and then stops the checking for a matching value from that point forward. When I go into the demo here, I think you'll understand exactly how that works. It's a little hard for me to explain it in English, but in code it's actually quite easy. So why don't we go ahead and jump right into our first demo and take a look at branching mechanisms that are available to us in C#. Now, when I move to my next slide, it's going to take me out to my view sharing demo, and my computer screen is set to 1024 by 768. So if your screen is set to that or higher, you can press the F5 key on your keyboard, and that'll maximize the display so you can see my screen full screen. And then when we're done with the view sharing demo, you can hit the F5 key again, and that'll restore your display back to the normal live meeting console. One other thing, please, if you have any questions, go ahead and type them into the questions and answers panel there, and I will answer them verbally as I come back from each one of the demos here. Okay, so our first demo is a real simple one. We're just going to build a couple little bits of code here to demonstrate looping. The first one that we're going to do, to demonstrate branching. The first one that we're going to do is we're just going to take a button and we'll place it on here, and we'll call this the if statement button. And in our if statement button, what we're going to do is we're going to do a very simple if statement. Let's call that if statement. So when I double click on it, we get our code. So I have if statement is clicked. Now, the way I'm going to do this is I'm actually going to build a very simple method that's going to return, it's going to be basically an expression that we're going to use. And we're going to be able to use it to test all of our other code. So let me just build that method real quick. It's just going to be a private method. It's going to return a number, an integer in this case, and we'll just call it expression. And our method is simply going to return some value. Let's just make it 3 to start off with. Okay. So whenever we need to use an expression, we're just going to use the keyword expression here, and then it's simply going to return a 3. We're going to be able to change its value depending on how we want to do that. So let's just go ahead and test that real quick to make sure it actually works. The first thing that we can do to test this is we can just simply say expression, just like that. Notice that we're not doing anything with return value. In C#, it's perfectly legal to do that. So when I run the code and I click the if statement, nothing happens because we didn't tell it to do anything. So that's doing exactly what we told it to do. It did return a 3, though, through the path. And we can actually see that by simply going to and putting in a message box, show, and we'll just simply say expression.toString. So now I'm actually going to display the results of our expression. So we have now a 3 value coming back, so we know we're getting our result from our expression. Okay, so now that I have that, we can start using that. And what I can do is I can use the very simplest form of a branch, and that's what we call an if statement. And the if takes one parameter. It takes an expression as a parameter. So I can simply say if expression. In this case, we can check for a value. We can say equals 3, then do a bit of code here. Okay. Now, in this case, we don't have any code there, but let's just go ahead and copy this line and paste it in here. So if the expression is equal to 3, then go ahead and execute this code right here. So we'll go ahead and run that, click the if statement, and you can see the message box did run, so therefore the value is 3. But let's just change this condition statement here. Let's just check to see if it's equal to 1. Now when we run the button and we click the if statement, we don't get anything returned. And that's because if I put a breakpoint on here, we can actually watch this execution. As I step through here and click the button, when I hit the F10 button, the evaluation for the expression actually failed because the value is 1 instead of 3. So it's comparing 3 equal to 1. If 3 is equal to 1, then execute the code. But you'll notice that it fell right through that So it completely missed that line of code. And it missed it because our condition failed. Now what we can do here is we can say, okay, well, this is a very simple condition, but I want to know when this actually doesn't work. So we can actually use the else statement, spelled the other way. And the else statement allows us to handle every other condition, if you will. So let's go ahead and do that, and let's just say, instead of that, we'll just say value not found. Okay, so in this case, now when I run it, and I click the if statement, I get the value not found. If I go back and change this value back to 3 and run it, now I get the result of 3 that I expected. So what we see here is a very simple branching statement. If a value of some expression is 3, then do this. Otherwise, do this. Now we can make this simpler just to show you how simple the if statement is by simply saying true and false. If a condition is true, then do this code. If the condition is not true, then do this code. And I can run that, and we get the same thing. So notice it's saying 3 because we said, okay, the condition is true. But if I simply change this to false and rerun it, now I get the value is not found. So that what we're actually doing here is we're comparing some value and creating some kind of a conditional statement that allows us to express ourselves whether using the CPU's built-in compare function. So if it is a one value, do this. If it is another value, do something else. Now that makes it, that's a very simple version of that. Let's go ahead and take this same concept and expand upon it into a much more complex scenario. So let's take a button and place it underneath there. And then this time we're just going to call this our switch statement. And we'll give the button a good name. No spaces in the names. So now when I double click, I get my switch statement button handler. And what we're going to do now is we're going to use the exact same kind of concept here, basically duplicate this scenario, only using the switch statement that's going to allow us to check for additional values beyond the 3. So to do that in C#, I'm simply going to use a statement called switch. And just like we did the if before, we're going to put our expression in there. But notice in this case, I'm not actually putting in the conditional portion of that. Instead, what I'm going to do is I'm actually going to say case 3, colon, and then go ahead and start another block of code here where I'll actually take my same code that I have here and place it there. So now I have a block of code that's very similar to our if statement, except I'm using the switch statement. And instead of doing the comparison here, I'm actually adding the comparison down here. So I'm saying the case is basically saying switch this expression. If the result is 3, then do this. Now you'll notice that it has a red squiggly underline, and it's saying, hey, it cannot fall through from one case label to another. In our case, we only have one case, so that really doesn't make sense in that particular error. But if I added a couple more cases to this, let me just copy this code, and let's do a 1 and a 2, and let's just say 1. So we're executing different code. 2. Now you see on every one of these case statements, it's complaining that it can't fall from one to the next. What it's actually saying is it's saying, hey, this case is not valid by. We have to be able to say, okay, I'm done executing this code. Now we have this curly brace here, and normally that says we're going to execute this code. But the switch statement is kind of odd in that it actually needs one additional statement saying, indicating that you don't want the code to continue executing down here and down here, even when we're checking explicitly for this value. And the statement that we use in C# is called break. And what break does is it basically says, okay, I'm not going to fall through. I'm done processing this code, and when I'm done, I want you to fall all the way down here to the end. So what we'll do is we'll just go ahead and put in our break statement on each one of these, and that lets C# know that we're actually done with that particular instance of that case. Now, interestingly enough, I could, if I wanted to, make this a little bit more advanced and say, well, I want this one and this one to work, so case 1 and case 3. And if that was the case, I could actually do a go-to statement, or let's do this one. Let's add one more that says, okay, in this case, we don't know what the value is coming back, so let's case anything else. In C#, the keyword is default, and default is basically saying, okay, handle all other conditions. So let's just copy that, and we'll just say everything else is in this bucket. Okay, so what we have now is, in this case, it's going to check our expression, and depending on what the value is coming back, it's going to display either the 1, the 2, or the 3. If it's none of those values, 1, 2, or 3, then it'll fall through and automatically catch the default, which is handling all other conditions. Just like we have our if statement up here, we could use this as a catch-all down here with the else statement. So think of default as the else statement. Okay, so let's go ahead and run this, and we'll hit the switch statement, and you see we get the value 3. If I go back up to our code, and I change our return value from our expression to 2 and rerun it, I now get the text string 2, just same way as if I do let's do a 66, run it. In this case, I get everything else. So it fell through to the everything else expression. Now, there are a couple other things that you can do here. If, for example, I had a case 3 or a case 4, in this particular case, it'll check the value 3 or 4. And actually, let's just change it to 3. Rerun it. So there it got the value 3. And if I put 4 in, we also get the value 4. So you'll notice how that there are two acceptable answers for this block of code to run in this particular case. So case 3 or case 4 actually meet the criteria for that. Interestingly enough, there are a bunch of different ways that you can actually make this case statement work. This just shows you a couple little minor examples of how we can do that. One other thing that we can do here, I did mention this earlier, we can actually say, okay, here we have the 1. Let's go ahead and make 1 a special case that actually executes this code as well as this code. So let's do that. Go to default. And if I change the value to 1 up here and rerun it, click on our switch statement, we get the 1, and then we get everything else because we told it both to run. So you can see in this very simple example here, we can get some pretty complex branching scenarios where I have multiple values being resulted in the same code executing, or I can have multiple paths executing different bits of code. As you see, the default's being executed when the 1 value is selected as well as when everything else is selected. So that gives you an idea of some of the more complex, simple versions of branching, if you will. And the way that we actually evaluate an expression is slightly different in the if statement as to the switch statement. Underneath the covers, functionally the code is identical. It's just that here we have our individual test here, and down here we have individual tests in each one of these blocks of code to check for those values. So you can do much more complex things with the case statement. I mentioned that earlier. Highly recommend you take a look at some of those scenarios. For example, you can do ranges if a range of values would trigger something. For example, this could be replaced with the range of between 3 and 4, or 3 and 300 if you wanted. It doesn't make any difference. And you can also make much more complex expressions here than the simple value. So here we have a simple value, an expression resulting in some value, and you can make one a more complex scenario that's maybe based on some multiplication factor or something like that. So lots of availability to make some very fancy statements with your C# code. Okay, back over to our slide deck, and So there is a question in the queue here, and the question is, can I write a go-to statement for one of the other cases, like I did a case 3? So in that case, what we would do is we would basically say, just like I did the go-to default, what I actually would do is say go-to case 3. In fact, let me just go ahead and write this code real quick, pop you back into the slide deck so you can see. What I just did is I just changed the break statement here from a go-to break statement and switched to a go-to case 3. Case 3 actually falls through here. I can make this 4 or whatever. And what this is doing is it's just like the default. It'll jump down there and execute that code. In this case, we're going to do the same thing. So I'm going to go up here, got the value changed to a value of 2. And so when it hits this case 2, it's going to go through here, show us the text 2, and then it's going to go to case 3 and execute that code. That code is actually just showing us the value. So when I run this, I hit switch, I get the text value 2 like I expected, and then I also get the string value, the number 2, as well, because I told in our code to go ahead and execute case 3 as well. So the answer to your question is yes, it does work the same way. All right. Now, a little bit more advanced version of the if statement, or branching in this case, is something that we call a loop. And a loop is where you have a bit of code that executes over and over. So normally when you're executing code, it just goes down linearly. But if you think about a loop, it's going down linearly, then it jumps back up a few instructions and starts repeating those instructions. Now, we can do that in several different ways, and the simplest way to do a loop is just to blindly say, okay, just start looping. And we do that with a statement that's called a do loop or a while loop. A do loop is a loop where we actually have a conditional check, an unconditional check. A do loop just simply loops and says, okay, continue to do this. But most of the time when we're doing a loop like that, we want to have some limit on how often it occurs. So you're going to add somewhere in there some kind of a test of an expression where you're actually going to check to see if a value meets a certain value. And if that's the case, then you're going to exit the loop. Now, the difference between a do and a while is that we actually test before or after the first instance of the loop. So you might process all the way through the loop one time and then check for the condition, or you might check for the condition before you actually enter the loop. And that's the biggest difference between the two. Interestingly enough, though, a do, the way you actually check for a condition is you use a while statement. So technically we're using a while loop that either occurs before or after the first loop. But if it's after the first loop, we're going to use the do statement to kick it off. So let's go ahead and add a couple do while loops to our code here and see how that affects what we're doing. Okay, so back over to our code. Let's go ahead and put a couple buttons on here. The first one that we're going to do is a very simple while loop, just to show you how that looks. So this will be the while loop. And so the while loop basically is where we're checking the value of an expression. And remember we have our expression method up above, so we can simply say while some expression is true, or some expression, let's say expression is equal to 3. Do some bit of code. Now, interestingly enough, because our expression is never changing, we need to, this would continuously run forever. So that would be the same thing as saying while true, do some kind of a loop. So let's do a box show in the loop. So here I'm in this loop. If I go ahead and run this and I hit the while loop, every time I click this, I'm going to get the in the loop mechanism here. So I'm going to stop that code executing because it will never end this. This is what we call an infinite loop. It will continue to run forever. So instead what I can do is I can actually put some kind of a condition that can be met. That way it runs a certain amount of times. The way I'm going to do that is I'm going to simply set up a very simple counter, and we're going to initialize it to 0. Now, technically, you don't have to initialize it to 0, but I want to make sure you guys see that the value starts at 0. And then what I'm going to do is say while I is less than our expression, and our expression up here, remember, I think we set it to 2. Let's go ahead and set it to 3 for our test. So it starts at 0, and while this value is less than our expression value, which is 3, display this message. And then what I'm going to do is I'm going to tell I to add 1 to itself. So I equals I plus 1. Very simply, this statement right here can actually be shortcutted a little bit to I plus plus in C#. So that's basically saying, okay, add the value of 1 to this value I. So in this case, as we go through here, I is going to be incremented. So every time this loop executes, I will get bigger by 1. And eventually, I is going to become equal to expression, at which point the loop will stop. So let's go ahead and run that, hit our while loop. So there we get our first iteration, 1, 2, 3, and notice that it ends. It ended because our expression evaluated to 3, and the expression, that value of I was also 3, and because 3 is not less than 3, it is equal to, because it is not less than, it failed. So while this condition was true, I was less than the expression value, it was executing that code. Again, if I would have commented this line out here that added that value, this loop would have ran forever because that value 0 would never be greater than an expression. So that's a while loop. Now, a while loop is a pretty simple loop. We can actually look at the values here, and as a matter of fact, let's go ahead and do that. As we look at the value here, if I is less than the expression, actually, let's go ahead and let's change this value to 3. And watch what happens. When I change its value to 3 and hit the while loop, notice that the code never executed. Okay? The reason the code never executed is because this value was never less than this value. Therefore, this code would never run. But let's say in our particular example, we wanted it to run at least one time. We can actually take this while statement and move it down here to the end, and instead put a do loop up here at the top. Okay? And the do loop, let's see, there we go. Boom. So here we have a do while loop, and in this case the do loop is actually going to execute this code and then check the value afterwards. So if I run this time, we actually get in the loop, even though our condition fails at the very end. So this test never would have succeeded correctly. This is something you want to be careful of. The test never was valid. Because I even started off greater than this. If I made this 999, 1,999, that value is still going to be greater than this. Even in that case, this code will still run. So it's not even close, but the code is continuing to run. So you want to be careful which loop you choose to execute your code. A do loop will continue to run regardless of whether the condition is passed or not, at least one time, where a while loop with this test at the beginning will only execute if the condition is true. But that gives you a little idea of a difference between a do and a do while loop. So let's go ahead and go back up to here. Oh, I do want to do one other little thing here. Remember how we had the I++ inside here? If I take this and put this back up at the top here, and I delete this, here I have the I++ line. If I comment this line out, I can actually put it here. And what this will do is it will, every time it iterates, it will automatically make that same test. So if I turn this back to 0 and I run this, we get our loop, 1. So there's our loop checking. And in this case, it's actually taking the value that we have, incrementing it as it goes through, and checking against the expression. So while it's in there, it's doing that same test. So that's just another example. I'm going to leave this code like that for the demo download code later on. So that shows you what a loop is and how they work. Now let's talk about the very last type of loop that we have. There's two basic types of them, and this is what we call a for loop. Now, we saw how in my while code I can actually set a parameter and it'll loop that many times. Well, it turns out there's a specific loop explicitly designed for that. It is a loop that actually contains a counter and some kind of an initial starting value, and then also contains a test condition to compare the initialized counter with the initialized value. And it will automatically take care of the incrementing of the I value that we did before. That's called the for loop. And here's the syntax of the for loop. We start off with the keyword for, and the keyword for is just a standard loop indicator. But you'll notice that the expression in here is actually pretty complex. In fact, there's actually 3 expressions. The first one is the initialization of the counter. So we're defining an integer called I in this case, and we're assigning its initial value of 1. The second one is actually the test, and that's I is less than 5. So this loop will be true if this condition is met. This expression evaluating I is less than 5 is the actual test condition. And then the third one, this last one, is actually an interesting operation that gets executed to allow your code to automatically increment or change the value of this I. So on one line you can see that, okay, we have a value called I, and we're going to loop until that value is equal to 5, in which case it will, this test will fail. And then we're going to have I added to itself, or 1 added to I for every iteration of the loop. So this is a very handy loop when you have an explicit number of iterations that you need to make, or when you want to make iterations based off of some fancy formula. And I'll show you some cool examples of this in just a little bit. The second type of loop that we're going to look at in this for is another one that's called foreach. So a foreach loop is a loop that actually will loop through however many elements you have in a collection. So whatever type of object it is, it'll simply look and say, okay, there's 5 objects in this collection. It will loop through and process each one of them individually. And the way it does that is it'll take your collection of objects, or your array, as we call that in C#, and one by one it'll place that in this object O. And from that point on, we can use the O in our code to act as the individual element out of this array. So the loop will automatically iterate over each one of the elements in that collection so that we can process them individually. And that's a real handy loop. It's not conditional, so the test is a little different. In fact, the test in our case is actually there, but it's hidden. When we're looping through an array, there's going to be n number of elements in that array. And just like in our for loop above, where we had the initializer and the actual condition and the increment portion of the loop, we have the same thing here, except that it's hidden and it's doing it based off of an index of each object that it stores internally in that collection of objects. So let's go ahead and take now a look at the 2 different types of for loops and how we can actually use them in our code. So back over to my desktop, and let's go ahead and put 2 buttons on there this time. So we'll do a for and a for each. So this will be our for button and our for each button. Okay. So there I have those. Let's go ahead and double-click those to get our code behinds. I guess I better stretch that out a little bit. There we go. Okay, so in our for loop, what we're going to do is we're just simply going to take create a very simple loop just called a for. And in here, we're going to do just like we did in our sample code there. We're going to create a variable. We'll just call it I. I happen to use I for what loops in all of my code. Just makes it easy. And then I'm going to set up some kind of a test. So in our case, it's I is less than some value. And we can hard code a value, or we can actually use our expression, whatever it happens to be. And then we'll do an I++, which actually indicates that just like what we did up here, we're incrementing this value of I, we're doing the same thing here. So now I have a check to see if I'm going to against this expression, if I is less than whatever the value of that expression is, and let's just make sure it's a good value. It's 3, good. So now I can simply say, okay, we're going to copy this line of code, paste that in there, and now you can see actually with this, what I actually wind up with is my initial value, the expression, and what's going to happen with the counter as we loop through here. And it gives it to me in a little bit more readable format. So if I run this code and hit the 4 button, I get the in loop 1, 2, 3, and then I exit out of the loop. So our expression value is 3, and while that value is true, while that expression evaluated to true, meaning that the value of I was less than 3, it processed it. Notice, however, that when we process this, as a matter of fact, let's go change our expression to 0. Let's make that 0. So now what's going to happen is this test will never be true, so 0 will never be less than 0. It's actually equal. When we run the 4 button, notice that it doesn't execute that code. Okay, big difference between the do while and the for loop, where we have the test condition at the end. In the for loop, the test condition is in the very beginning, so it will not execute this code unless this expression evaluates to true, something very important to understand. There's actually a couple other cool things that you can do with these for loops that a lot of people don't realize. So in this case, I have the int I equals 0, but it turns out I can also do other values in here. So I might have other iterators or things like that, or I might have other commands. Well, the for loop is actually pretty powerful in that you can actually have multiple values in these 2 particular fields here for the for loop. In this case, I could say int I equals 0, comma, int j equals 5, and over here at the end, I might have something like j minus minus. Okay. Now, actually, I don't have the syntax quite right, but you can actually add multiple commands to those as you go through this, and actually have it process individual elements inside of here, having multiple complexity to this loop. An example of this is if you were building a 2-dimensional array of objects, something a little bit more complex than what we're normally doing. But let's say I was building a map and I have an x coordinate and a y coordinate, and I want to iterate through both of them, maybe draw a diagonal line or something like that. I could actually build a for loop that does that all in one expression. Or another way of doing that is to have another for loop where you have a second value actually processing it. So j is less than expression and I or j plus plus. So this is another example where you have what's called a nested for loop. I have one inside the other. Now, one thing you want to be careful of is when you're building these loops like this, you don't want to get confused and put an I inside there. Or worse, put an I over here where the test is wrong. So in this case, you want to be careful. I'm using this particular variable j, but in my test condition, the value is I, and this would fail out. As a matter of fact, this would continue to run incorrectly because this is actually pretty hard to spot, especially when you consider j, the subtle difference between the j and the I from the character set. You can actually look over this code 27 times and miss that very, very subtle difference there. So you want to be careful of that. But in this case, what will happen is, well, if I put the value to 1, we're going to get one iteration of this and one iteration of this. But because there's one iteration of each, we should wind up with, as we look at this, in the loop happening only one time. Think about it as a multiplier, 1 times 1. If we do it by 2, we'll get, a much more substantial. So there's 1, 2, 3, 4. So 2 times 2 is 4. So that's an example of for loops. Now, the other type of for loop that we talked about is this one called the for each. Now, the for each is a interesting loop in that it doesn't care that there is a condition or not. It doesn't check the value, doesn't compare it to anything. It just checks to see how many elements are in a particular collection or an array, and it processes each one of them individually. So let's go ahead and build a for each. But before we do a for each, we actually have to have something for it to iterate over. And what I'm going to do is I'm going to build a very simple collection or an array of numbers that we're going to call primes. So my prime numbers are going to be a new array, and you don't need to worry about the array syntax just for right now. But we're going to start off with 2, 3, 5, 7, 11, 13, 17, and 19 ought to be good enough. So what I've just done is I've created a collection of prime numbers, and these are the prime numbers that we're dealing with. And now that I have that, I can actually spin over using a loop to execute each one of them individually using this for each statement. So I have this for each, and our statement is going to be for each integer that we're going to call I in our my primes collection, then do something with that. So in our case, we'll just do a message box .show, and then we could do some text. The current value is plus I dot toString. So in this case, what it's going to do is it's going to take our text string, the current value, and actually display that text. So it'll loop through each one of these. Now let's go ahead and run that. Hit the for each button. The current value is 2. The current value is 3. And as I keep going through here, it'll increment that value. Notice that 19 is the last value, so this loop will end automatically there. It makes no difference how many prime numbers we have in this collection. It will spin through and faithfully process each one of them individually, as if I knew exactly how many were to begin with. It turns out that there is some built-in code behind an array that allows it to know how many of the elements there are. So underneath the covers, our for each statement actually turns into a very cool version of the for statement, where it knows that there is the first value is 2 and the last value is 19, and it just spins through and knows how many elements are in that array. So this gives us a good way of dealing with that. Now that we have our for each statement, we can actually do much more complex things with this. For example, we could take advantage of some of the other statements that we've learned here. So here we have our switch statement, and I can actually take this switch statement and go through here and process, copy this entire thing. I'm missing the bottom. There we go. Copy that and put that right inside our for loop here. And instead of doing the expression, I'm just going to look for the value I. In our case, we go 1, 2, 3, 4, and whatnot. So we have some of those values here. We have 2, 3. And we can even change this to, let's make this, actually we'll just leave it like it is. Let's make this first one case 11. So it's going to trigger on that case 11 there. And everything else is actually going to fall through here. So now when we run our code, we get our for each. The current value is 2, and it displays 2. It displays 2 again. The current value is 3, 2. So our logic is there's a value that doesn't fall in it, so the value 4 is everything else. The current value is 7, falls under everything else. The current value is 11, so we should see 1 now, and there it is. So we have some interesting logic here. It looks kind of screwy as we're going through it, but when you follow this logic, we're actually processing each individual value inside here. So we're looking at every one of these values and processing it differently depending on how it falls through. Now, some of that messed up logic is where we actually did this go to default and go to case 3. Normally we would have break statements in there, but this just shows you how you can really take advantage of the C# and make the code do exactly follow the exact route that you want it to follow. So hopefully it gives you an idea of what some of the things you can do here. In this case, we can drill this down even further. So for example, here we have the case 11, and I can actually check to see if the value is 1 or 11. If that was the case, 1 or 11, then we could process that however we wanted to do that. Here's another example where we did that already. And then we could not just use simple integers, but these can become very complex objects. So it might be for each person in a collection of customers that you process it. So I built that person class the other day. As a matter of fact, in our next episode, we're going to be talking about objects and classes, and we can use a class to define a person, and they can then create an instance of that person and call that an object, and we can have a collection or an array of those objects, those customers, if you will, and spin through each one of those customers using this for each statement. So in that case, it's not even a number, it's actually an object. It might be, number of stars in the sky. For each star in the sky, collection of the sky, do something with it. So there's a lot of cool things that you can do with loops like this, as you can see. All right, back over to our slide deck. So today we took a look at branching, the various types of branching using a very simple if statement and a little bit more complex version of the if called the switch statement that allows for multiple conditions to be met. And then we also went through and took a look at looping, which is a very heavily modified version of a branch where we can loop multiple times. We can repeat a set of code based on a set of criteria that we have, whether that be a simple expression or whether it be through simply a collection of objects that are available to us. Now, speaking of objects, next week we're going to be talking about classes and objects. And classes and for some reason it says January 8th. That's certainly not correct. It's next week. I say next week. Technically, it's in 2 weeks. I'm on vacation next week. But in 2 weeks, we're going to be talking about classes and objects. And a class, like I said, is a definition. It's a blueprint for an object, and an object is actually an instance of it. So think about a house. You build a house based on a set of plans. You can live in a house. That's an object. You cannot live in a blueprint. That's a design, which is what the class is. So we're going to talk about how code can be implemented in classes and then utilized as objects. So I do want to thank everybody for watching today. Again, I will be out next week. I'm on vacation, but in 2 weeks, come back. We'll talk about objects. Please feel free to follow me on Twitter at WJSteele. Always putting cool little things down there. And my email address, if you want to get a hold of me, is wsteele@microsoft.com. Feel free to do that. And right now, I'm going to actually turn you back over to Tracy so she can get you into the survey. Please, please, please fill out that survey. Let us know how we're doing. Let us know what you want to hear. And let us know how we're doing and what we can do better for you. Tracy?
Excellent. Thanks, Bill. So what everybody should be seeing out up on the screen is this survey, and you just want to follow the links provided to complete the evaluation. And like Bill said, we really do appreciate the feedback you leave there for us, so please do fill it out before you log off. Now is also a good time to submit your questions into the Q&A pane. Just type them in and hit ask, and we will get to those here in a moment. Also, the slides from today's presentation are available as a printed PDF. If you go to the bottom right-hand side of your live meeting screen and you click on the printer icon, you can print the slides or save them locally for your convenience. And so, Bill, do we have any questions waiting there for you?
Michael's asking, what's my Twitter again? And I'll put it right in here for everybody. It's at WJSteele, at WJSteele. And that's the only question I have. Everybody have a great week off.
All right. With that, I do want to extend a very special thank you to you for presenting today, and a big thanks to our attendees. Well, ladies and gentlemen, that's going to conclude today's session. You may now disconnect from the audio portion of today's presentation.